Hi everyone, this is Dr.K.Sakthivel, Associate Professor from Department of Electrical and Electronics Engineering. In this video, we are going to discuss about battery in electric and hybrid vehicles. Course code is U18Oeau001. Course aim is electric and hybrid vehicles. So battery is one of the important source in our electric vehicles. Okay. So first we will see introduction about battery, okay, and the introduction about electric vehicles also. The basic requirement for electric vehicle is portable source of electric energy, which is converted into mechanical energy in the electric motor for vehicle propulsion. So in previous video also, I just said about electric vehicles introduction. So motor will convert electrical energy into mechanical energy, and generator will convert electrical energy into mechanical energy into electrical energy. Okay. So in electric vehicle, both operation will happen. Okay. So while riding a vehicle, controller will take the energy from the battery and it will use to the motor. Motor will convert that electrical energy into mechanical energy. If you have sudden obstacles in the road, then we are applying a brake. That time, motor will act as a generator. It will convert the mechanical energy into electrical energy and it will be stored in the battery. Okay. So like this only happening in our conventional vehicle as well as in our electric vehicles. Okay. So we have to charge the battery. Okay. So for the charging purpose only, this generator concept is functioning in our electric vehicles as well as our conventional vehicles. Okay. So battery is very important. So if you want to start the electric motor, initially you need a battery source only. Okay. So it may be depend upon the consumer needs. It may be vary from 12 volt to 48 volt, 60 volt, like that. Okay. And AH, battery capacity also. Okay. Ampere per hour. How much amps it will be delivered to the motor per hour. It will be calculated as AH. So in this video, we are going to see about battery parameters, types of battery, and what are the batteries, where and all we are using, and how to calculate the battery capacity, charging rate, discharging rate, depth of discharge, and connections of battery, that is series and parallel connections. Okay. So electrical energy is typically obtained through conversion of chemical energy, and it is stored in a device that we call it as a battery. Okay. Actually, motor will convert electrical energy into mechanical energy. Generator will convert mechanical energy into electrical energy. Battery is converting chemical energy into electrical energy, which is stored in the battery. Okay. There is a chemical conversion is happening inside the battery. So due to that only energy is stored inside the battery. Okay. So a flywheel is an alternative portable source in which energy is stored in mechanical form and to be converted into electrical energy on demand for vehicle propulsion. Okay. So here that vehicle flywheel only converting the energy, generally it is in the form of heat that is stored in the mechanical form and to be converted into electrical energy on demand for vehicle propulsion. Okay. So like that only battery is charging while we are riding a vehicle. Next, battery basics. Batteries are made up of unit cells containing the chemical energy that is convertible to electrical energy, or one or more of these electrolytic cells are connected in series to form one battery. For a simple understood purpose, let me take example for UPS battery. Almost everybody have inverter in your home that consists of inverter as well as battery. That unit we call it as a UPS. Okay. So almost we have seen that inverter batteries, which is lead acid battery, and in that lead acid battery there are 6 cells or 8 or 12. It's depend upon the battery range, the battery capacity. So there will be a knob in the top of the battery that is considered as each and every cells, okay, that is packed together and it will be placed in battery module. Okay, that is battery basic actually. So here I mentioned in the second point, okay, the grouped cells. Each and every knob is there no in your battery that we call it as a cells. That cells are grouped together and are enclosed in a casing to form a battery module. Okay. A battery pack is a collection of these individual battery modules and it may be connected in either series or parallel combination to deliver the desired voltage and energy to the power electronic drive system. Okay. So each and every battery cells are connected in series as well as or in parallel to form a battery pack to deliver the power to the electronic drive system. Based on consumer needs, the battery connections may be connected in series or connected in parallel. Next, we see how a battery works. Here I have an animated image. So let's see how battery is working. A battery is a device that stores chemical energy and converts into an electrical energy. The chemical reaction is happening inside the battery, which involves the flow of electrons from one material to the another, okay, through an external circuit. If you have a battery, you can see two nodes. One is positive terminal and another one is a negative terminal. So that we call it as a cathode as well as anode. Okay. So through an external circuit only, we can make a flow of electrons from battery to the external circuit. Okay. So the chemical reaction is happening inside the battery only through the electrode. Okay. The flow of electrons provides an electric current that can be used to do work. Okay. So electrons is coming out from anode, it goes to the load and come back into the cathode. So there is a flow of electrons here is showing in the animated picture. That flow of electrons only gives energy to do whatever we are connected in our circuit. The conversion of energy from chemical to electrical is known as charging. We all know that. So the conversion of energy from chemical to electrical, we call it as a charging. And the conversion of energy from electrical to chemical is known as discharging. Okay. Initially, inside the battery, we have charge that is converted by electrical chemical energy into electrical energy and it's stored in the battery that we call it as a charging state. Okay, once we have started using a battery, that battery energy will be discharging. Okay, that means that electrical energy is converting into chemical energy. Okay, so that we call it as a discharging, battery discharging. Difference between capacitor and battery. Okay. So why we are going for capacitor? So as I said earlier, battery will occupy more space as well as more weight to our electric vehicle. So some researchers have designed instead of battery, they are designing capacitors, ultra capacitors, super capacitors. They have tried, but it won't work as battery efficient. Okay, so here we will discuss some points why battery is better than capacitor. Okay, in capacitor, first point, potential energy is stored in the form of an electric field. So both capacitor and battery store energy. Okay. In capacitor, the potential energy is stored in the form of an electric field. In battery, the potential energy is stored in the form of chemical. Okay. Capacitor draws energy from the circuit and stores and then release the energy. You have to listen clearly to this point. Capacitor draws the energy from the circuit. That means it is not initially stored the energy stored in the device. It will take the energy from the circuit. For that circuit, it may be supplied through battery only. Okay. So whatever energy or DC source, some other DC source. Okay. So whatever source that is supplying to that circuit, it will take that source from the circuit and stores little amount of energy in inside the capacitor. And if needed, it will release that energy. But in battery, here it is a primary source. Thus, the battery provides energy to the circuit. Okay. So it won't source energy from the circuit, it is delivering energy to the circuit. Okay. It's not like a capacitor. Capacitor is a passive component of the circuit and it is active component of the circuit because it's taking energy from circuit, no, therefore it is called as passive component. It is delivering power to the circuit, so battery is called as a active component. Then coming to the capacitor, it is generally used for AC applications. It blocks the DC component of the circuit. Okay, so there may be some ripples. So to avoid that, so generally capacitors may be used in our AC circuit. It is in coming to the battery, it is used as a DC component. Okay. So capacitor voltage gets rapidly decreased. Once we don't have power in the circuit, then instantly capacitor will release all the energy stored in it. Okay. That we call it as a rapidly decreased. Okay. But in battery, there will be a constant voltage discharging. Okay. It won't suddenly discharge the energy. It will constantly release the energy according to the consumption. Okay. Then coming to the capacitor, its charging temperature is minus 40 to 65 degrees Celsius. Okay. And the battery charging temperature is 0 to 45 degrees Celsius. That's why battery won't use in very heat environment, very hot environment. Okay. So if you are using in your home, our room temperature will be 25 degrees Celsius only. At a very hot summer season, it will reach 32 or 34. That's all. Okay. Till now, we are not reached 40 or so. So battery is suitable for our environmental condition. Our present environmental condition, battery is suitable for all cases. Okay. Better it will be avoided in thermal industries maybe. Okay, you can't use it that. There may be room temperature. It will go beyond rated temperature in our battery. so it is not good for our thermal industries. Okay. So capacitor service life is 10 to 15 years, and the battery service life is 5 to 10 years. Okay. So each and every manufacturer, they will give you a warranty and guarantee period for 1 or 2 years. Okay. So definitely 1 or 2 years, our battery won't affect, our battery won't bulgy. Okay. After 2 years, 3 years only, there may be bulgy in our battery case. Okay. That is happening due to less um maintenance of our, that is no maintenance of our battery only. Okay. We should take care of battery every day in our daily life. Okay. So as I said earlier, there are 6 cells or 8 cells uh, in the battery case. We have to check their water level daily. Okay. Not only in our home, as well as if we have a two-wheeler or four-wheeler, we have to check a battery level in that, water level in that battery. Based on that water level, our battery life will be extended. Okay. So there will be a regular periodical checking of water level in our battery. Okay. We have to do it regularly. Then only, as per manufacturer warranty, we can use our battery. Okay. So this is the difference between capacitor and battery. So from this comparison, we all understood that battery is most promising source of energy for our electric vehicles, and capacitor will be suitable only for designing a electric circuits. Okay, it is not good for delivering power to our electric vehicles. Types of battery. There are two types of batteries. One is primary battery and secondary battery. So primary batteries, that once it's charged, we can't recharge it again. That we call it as a primary battery. That is, you have to use that battery and throw it out. That is single use. That we call it as a primary batteries. These primary batteries are generally used in our watches, calculators, camera, like that. Whatever toys we have in your home, in that we are using, remote battery or toys, whatever. Okay. For that only we are using this primary batteries. Once if discharged its all energy, then we have to throw it out. Okay. That type of battery we call it as a primary battery. And the secondary batteries, we call it as rechargeable. We can able to recharge that battery once it loses all its energy. That type of battery we call it as a secondary batteries. Okay, so secondary batteries used in small gadgets like trimmer and many other home gadgets we are using. You can take example as our mobile phone also. We are entirely we are recharging that battery now, so that comes under secondary batteries only. So while considering electric vehicles, secondary batteries are most suitable for riding a vehicle. Okay. So that chemical reaction process during the cell in charging operation, that electrical energy is converted into chemical energy, is the reverse of that during discharge. This point we already discussed in the previous slide. So chemical energy is converted into electrical energy. We call it as a charging state, and electrical energy is converted into a chemical energy, that we call it as a discharging state. Okay. The batteries needed and used for EV and hybrid electrical vehicles are all secondary batteries only, because they are recharged during regeneration cycle of vehicle operation or during the battery recharging cycle in the stopped condition using a charger. Okay. So in previous video, I shown that block diagram, that is from charger it is connected to the battery, and from the battery it is connected to the motor, to controller. From the motor it is connected to the transmission unit. Okay. So that from that charger only we are charging our batteries, that we call it as a plug-in electric hybrid vehicles. Even though our vehicles in top condition, we can charge our batteries by using charger. Here you see what are the major types of rechargeable batteries considered for EV and hybrid electric vehicles. Okay. Right now we are using lead acid batteries only. Okay. So lead acid batteries are comparatively it is cheaper than lithium ion batteries, but it will occupy more space as well as weight. That is the disadvantage of lead acid battery. Cost wise, it will be advantage. Next, we can use nickel cadmium and nickel metal hydride lithium ion batteries. In our mobile phone, we are using lithium ion batteries only. We all know that lithium polymer batteries is there, sodium sulfur is there, zinc air batteries also is there. Okay. So here are some of the images of batteries. First one is lead acid battery. It is very popular in all industrial as well as commercial and domestic applications. Okay. Most probably are using a lead acid batteries only. For our present conventional vehicle also, we are using lead acid batteries. And secondary, we call it as a nickel cadmium battery. It is also a rechargeable battery, which is used in our small gadgets like a hair trimmer. Okay. So and cameras also we can use this type of batteries, that is nickel cadmium batteries. And the third one is lithium ion batteries, which is using in our mobile phones right now, and the same model with we are extending our usage for our electric vehicles. So let's imagine in the same size or with the multiple packs, it can be used for our electrical vehicles. Means we can easily fix it wherever you want. Okay, it won't occupy more space and weight also. It is very convenient for our electric vehicle. So we can provide more space for in our electric vehicles if you are using a lithium ion battery. The only thing is, in compared to lead acid battery, it will be costly. That's all. But in future, it will be with more battery designs, more manufacturers comes across with lithium ion batteries, then there will be a competition between each and every manufacturer. Then there may be chance of dropping prices in lithium ion batteries. We expect that condition soon. So let's go for lithium ion batteries. It will be most promising for our electric vehicles and for all our home applications. Okay. And lithium polymer batteries is also there, and zinc air batteries, button shape type is there, no? That is zinc air battery, and lithium polymer battery, which is used in our laptops actually. We are all having laptops. So once your laptop battery is uh, uh, the battery life is gone, means you just replace that battery by a new one. That time, simply throwing out, you just open that battery case and see the battery type, how they are connected inside the laptop battery. So whether it is a series or parallel connection, just see the battery type. So in last type I mentioned, no, it's the crystals that only used in our laptop batteries. Actually, lithium polymer batteries, that is. Okay. That also salt batteries comparatively are connected, and it will support 36 volt or 24 volt for our laptop. It will work for 4 hours, 5 hours. Okay. So with a regular recharging, your battery life will be uh, presented. Okay. So these are the types of batteries and types of images also I mentioned here. So we are using in all applications also so this kind of batteries. But in our electric vehicles, in future we are going to use lithium-ion batteries only. Next, battery parameters. Battery capacity. First one we will see about the battery capacity. The amount of free charge generated by the active material at negative electrode and consumed by positive electrode is called a battery capacity. So in the animated image I shown that through electrode ions are moving from anode to cathode node. So that is called as a battery capacity. The battery capacity is measured in terms of AH, that is ampere per hour. So that is a unit of battery. So ampere per hour, that means for per hour, how much ampere that the battery can deliver to the load. That is measured in terms of AH. Okay. So that is battery capacity. Next, discharge rate. The discharge rate is the current at which a battery is discharged. The rate is expressed in terms of Q by H, where Q is the rated battery capacity and H is the discharge time in hours. For a battery that has a capacity of QT AH and it is discharged over T, the discharge rate is mentioned as QT by T. That is charged battery, we call it as a Q, right? So discharge rate is nothing but per hour how much that charge is discharged. That is calculated by term Q by H. Okay. At present stage, how much energy it has and how much energy will be discharged per hour. That will be calculated in respect to time. Therefore, we call it as a QT by T. That means QT by T into AH. So how much of energy it will be discharged at a particular time, or how much amount of energy it will be discharged, or how much amount of amps it will be discharged per hour with respect to time. That we call it as a discharge rate. Next, state of charge. The state of charge is measured as SOC. It is the present capacity of the battery. If you want to calculate the present capacity of the battery, then the state of charge is used to calculate the present stage of our battery. It is the amount of capacity that remains after discharge from top of our charge condition. Okay. So once our battery is fully charged and they are using it for a period, so after that usage, we have to calculate that the state of charge means we have to use this expression I of t equal to dq by t. That will be name it as a state of charge. Simply, if you are having a mobile phone, in mobile phone, there will be a option we can able to see how much percentage you have and how much percentage of charging while we are putting a charge, how much percent of charge at present it have, and at a certain period it will be charged, and we can also see how much percentage is increased after charging. Once it is fully charged 100%, then we are start using our mobile. Then at a certain period it will be discharging. That will also indicate that no. So like that, it will be calculated in terms of I of t equal to dq by dt. Okay, that we call it as a state of charge. The current is the rate of change of charge given by I of t equal to dq by dt. Okay. This will be represented in terms of time, then it will be called as SOCT of T is the amount of equivalent positive charge on the positive electrode. Next we see state of discharge. The state of discharge is mentioned in terms of SOD, is a measure of charge that has drawn from a battery, and the state of discharge is also in mathematical graphical form it is given here. So at the initial stage, at the initial charging condition, your graph is at peak point, that is EV is nothing but battery charged condition, fully charged condition, and SOD is nothing but state of discharge. Once you are starting using battery, that full charge will be started reducing gradually at a time of QT. So your battery level will be low, and it indicates you have to put charge for our battery. Okay, that is the state of discharge. Next, depth of discharge, that is mentioned in terms of DOD, the percentage of battery capacity to which a battery is discharged. The depth of discharge is given by DOD equal to QT minus SOCAT divided by QT into 100. Okay. So for simple understood purpose, you just remember the battery efficiency is 80%. Okay. That is the least depth of discharge. We can't use our battery beyond that 80%. So efficient of battery is 80% only. Okay. So we can't use beyond that. That manufacturer will be determine that depth of discharge. Next, battery pack design. Okay, there may be a configuration of battery packs. It may be connected in series, or it may be connected in parallel configuration, or in both combinations. It will be connected depend upon the consumer needs. The series connection yields the required voltage, while the parallel connection delivers the desired capacity for the battery pack for minimum runtime before recharging. The battery pack also includes electronics which are typically located outside the battery pack. The electronic circuits of a multi-level battery pack controls charging and ensures reliability and protection against the overcharge, over-discharge, short circuiting, and thermal abuse. This is the connections, parallel connections of our battery. In this parallel connection, positive terminal of one battery is connected to the positive terminal of next battery, another battery, and simultaneously negative terminal of one battery is connected to the negative terminal of other battery, and it keep on connected depend upon the consumer usage. So if you are connecting like that, then it will be called it as a parallel connection. So if you are connecting like a parallel connection, what will be happen means you have n number of batteries with the same parameters, that is 6 volt, 100, 10 Ah. If you are connecting in a parallel, see the difference. We can maintain the same 6 volt, but Ah is summation here. That is summing of Ah is happening in parallel connection. Okay. If some customers needed their battery is, their load is based on current, means they have to use battery in parallel connection. If their load is based on voltage, then you have to use constant voltage, then you have to use the series connection like that. Okay. So here voltage is constant and current reading is increasing. Okay. And the next we see the batteries in series connection. That is, batteries are connected from terminal to terminal in a way that positive terminal of one battery is connected with the negative terminal of another battery, and the negative terminal of one battery is connected with the positive terminal of other battery. For clear understood purpose, we just see the image. Here we have a positive and negative terminal of each and every battery. In the first battery of negative terminal is connected to the positive terminal of the next battery, and from the negative terminal of the same battery is connected to the positive terminal of the next battery. If you are doing connection like in series way, you see here the same 6 volt and 10 Ah battery is there. That voltage is getting doubled here, and current capacity is maintained same 10 Ah. Okay. So its connection is purely based on consumer needs. If they want series connection, then manufacturer will do series connection. If they want a parallel connection, then manufacturer will also connect parallel connection in the way how customer is approaching to the manufacturer based on their needs. Okay. This is battery connection about series and parallel. Okay, and battery properties, I given some points here. So for a lithium acid battery, you just see the efficiency, energy efficiency of each and every battery. Lead acid battery is 80%, nickel cadmium is 75%, nickel metal hydrate is 70%, aluminum air is less than 50%, zinc air is 60%, sodium sulfur 85%, sodium nickel chloride 80%, lithium polymer, lithium ion is greater than 95%. Comparatively, if you see the battery types and its energy efficiency, you understood that lithium ion have greater than 95% of battery efficiency. So that only all manufacturers of electric vehicles concentrating on lithium ion batteries. Thank you.